Hi everyone, and welcome to this video on our applications of integration. And in this particular one, we're going to discuss its application on determining the concept of consumer, producer, and the social surplus. So these concepts are critical to our concepts in microeconomic theory, particularly trying to measure the level of welfare. So as we will notice throughout the theory courses that we'll have, in a perfectly competitive market, we're going to have the highest consumer surplus and a zero producer surplus. And theoretically, it's in this particular market we're in, we're going to have the highest social surplus. But there are many types of market structures which may yield different results. But ultimately, the goal, at least to determine which type of structure or per, competitive economy has the highest amount of welfare, would generally lie in terms of the social surplus, at least in terms of its market efficiency. So these are concepts that are critical to understand. So we're going to try to understand them at least now using an integral. So let's go through these concepts one by one, right? So consumer surplus is essentially, it represents the welfare of consumers, as the name implies, and it's the extra amount that consumers would have been willing to pay but did not because they ended up paying an equilibrium price. So if you think about it, if you say this is like price and this is quantity, and say you had the demand curve here, and say that the price, the optimal price that was charged in the market is PE, that price. Now, there are people that exist. If you look at your demand curve, there are people that rest somewhere here, 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 right? Who were willing to pay a price higher than the equilibrium price. But because they follow the structure of the market, they only needed to pay the equilibrium price. So they have an extra surplus. They have an extra happiness in the fact that they didn't need to pay what they need, what they would have been willing to. They paid the equilibrium price instead. And that's a surplus to them. And essentially, it's this area here. So the formula is given by this integral, which is the area under the demand curve. So notice this is the demand curve dq. Okay, it's the area under the demand curve from PE. So if this is PE, this will obviously be QE. So from 0 until QE, so notice it's going to be the entire area under this curve. So the entire area represents this sort of red area there that I'm shading now. So this area here is essentially that. But the surplus part is only the area above the equilibrium price. So we need to take out P star times Q star, or this box here. So we need to take out the box. Hence, we're just left with that pink area that we've had earlier. So that pink area that we have, that is your consumer surplus, right? On the other hand, the producer surplus, okay, represents the welfare of producers or sellers, right? And it is the extra amount producers receive above the price that they're willing to accept. Thus, the producer surplus looks kind of like the opposite. So if you look at again a typical supply curve, the supply curve looks something like that. Say this is equilibrium price. So P is here. Therefore, QE would be somewhere here, right? Your producer surplus, okay, your producer surplus would be this area here, right? It would be this pink area here. And the way you're gonna get that pink area there is essentially you start with the entire box. The entire box is this red thing, right? That's the entire box. That's PE times QE, or P star times Q star. And you subtract the area under that curve, which is this blue thing here. So if you subtract from the big box, that blue thing there, you're left with the pink area, which is the producer surplus. And in the equation above, right, notice that this part here, this integral here is essentially that blue area that we have. And that P star Q star is that red box. So this is that box that we have there. So quite interrelated, quite similar in formula actually between the consumer and the producer surplus. And the social surplus is essentially adding both of them. So if you add both the consumer surplus and the producer surplus, you get the social surplus, or as some textbooks might refer to it as the economic surplus or the net market surplus. It's essentially a welfare measure of the whole economy under the assumption that, of course, the economy is just composed of producers and firms. I'm sorry, producers and consumers rather. Okay, so we have that formula being the one there. And graphically, we have this measure here. So again, consumer surplus is this area there, right? Consumer surplus is that area there. Producer surplus is this area here, right? And net market surplus is just if you add consumer and producer surplus. So that's that area over there, right? So in terms of an integral, let's just recall the integral. The consumer surplus is equal to the integral from 0 until q star of the demand function, dq. So this is, again, the integral represents the area under a curve. So this is the area under this demand curve. So this is the demand curve, the area under that curve, or which is equal to PQ, right? That's the area under that curve. But we have to subtract from it this this entire rectangle. So minus P star times Q star. PS function similarly, except that we put the box first. So that's P star times Q star less the area under the supply curve, because we're interested in the area above the supply curve below equilibrium price. So that's 0 to Q star SQ DQ, right? That's what we have there. Then this social surplus is essentially, as we've said, CS plus PS, right? And in terms of an integral, we just follow this form here, which is just social surplus, which is the integral 0 to Q star of your demand curve, the area under the demand curve, minus the integral of the area under your supply curve. So this is Q star supply curve, dQ. So I think we've got this concept down. We can sort of lay it out in terms of math now, in terms of an integral. So let's start with an actual example. So let's start with our example. So say that we're given with a market demand function. Okay, so let's go with a market demand function equal to P is equal to 50 minus 0.1 Q. Let this one be our market demand function. And we also have a market supply function, which is 0.2 plus a market supply function, 0.2 Q plus 20. And this is our market supply function. Okay. So we're given this, which is a market demand and a market supply function. Note that it's critical that it has to follow the typical rules of economics, which is the law of demand and supply. The market demand function has a negative relationship between price and quantity demanded. The market supply function has a positive, a positive relationship between price and quantity demanded. So those two things are met in our conditions here, right? So we're gonna now start to try to compute consumer, producer, and social surplus. So the first step for us to do, so step 1, is to calculate equilibrium quantity and the equilibrium price, right? So that's the step 1. Okay, and equilibrium quantity, that's just how we get these things is just we equate market supply, which is QD, is equal to QS. So if you remember that. But we know that these two things can be manipulated as such. So if this is your market demand equation, we equate it to just the market supply equation, which is supply equal to demand. So that's 50 minus 0.1 Q equal to 0.2 Q plus 20. I'm left with 0.3 Q, 30. I get, if I divide both sides by 0.3, okay, I'm gonna get a Q star, right? Q star equal to 100. Right? That's my Q star. And that's the equilibrium quantity in the market. So sellers and buyers agree if there is a quantity of 100. Now, we can calculate for equilibrium price by plugging in the 100 into either the market demand or the market supply equation. So let's go for the market demand. So that's 50 minus 0.1 times 100. We're going to be left with 50 minus zero point 0.1 times 100, that's 10. So we're going to be left with 40. That is equal to P star. Right? P star is equal to 40. Right? So we have that there. Then, so we now have the things we need to plug into our formula. Okay, so step two, let's get the consumer surplus. Right? The consumer surplus, again, formulaically, is the integral from 0 until Q star of your demand function, the area under your demand curve, but above equilibrium price. So we have to subtract that rectangle there. So in integral form, we take the integral from 0 to 100, because that's your Q star, of your demand function, which is 50 minus 0.1 Q dq, right? So we take the integral of that, and we subtract it from P star. P star is 100. Then Q star is 100 times 40. Right? P star is 40, Q star is 100. So we subtract it from that. Then we get, it's just going to be, if you take the integral of this is 0 to 100, 50Q minus 0.1 Q squared all over, minus 0.1 Q squared all over 2, right? Let me just fix this. So let's take it one at a time. So this is 50 integral 0, 100 Q dq minus 0.1 integral 0 to 100 Q squared all over 2. I'm sorry. This is already us solving it. My apologies. I'm getting ahead of myself. Right? So this is 50. Okay, 50. If we take the integral of 50, that's Q. And we evaluate this from 0 to 100. Okay, this is correct. Minus 0.1 Q. If we integrate Q with respect to Q, right? So this is Q squared all over 2. And we integrate this from 0 to 100 minus 4,000, right? And we're going to be left with 50 times 100, right? 100. And then we don't have a lower because that's 0, so that will just cancel out. Minus 0.1, okay, times 100 squared, right? 100 squared over 2. And again, the second one will just cancel out, okay? Minus 4,000, right? And we're essentially going to be left with 5,000, okay? Minus, we're going to be left with 5,000, okay? Minus 4,000, right? That's this 4,000. Then if you solve this one, okay, it should be equal to 500, right? So this is 5,000 minus 4,500. Our consumer surplus is just 500. Okay, that's what we have there. Step 3 is if we get our step 3 is essentially to get so let's get our producer surplus. Then our producer surplus is essentially, if we do this, so this is PS equal to P star times Q star minus the integral 0 to Q star of SQ, S capital Q, sorry, Q dq, right? And this is just going to be equal to P star times Q star. We know that that's 4,000 minus, we take the integral, okay, integral 0 to 100 of our supply function. Our supply function is 0.2 Q plus 20 dq. Simplifying this, you get 4,000 minus 0.2 times Q squared all over 2, evaluated 0 to 100, plus 20, I'm sorry, minus, right, minus, okay, minus 20 times Q evaluated from 0 to 100. This one will be equal to 4,000 minus 0.2 times 100 squared all over 2. Okay. Then the 0 again cancels out, minus 20 times 100. You're going to be left with 4,000 minus this one will be equal to 1,000 minus 2,000. Therefore, you're going to be left with 1,000. And that's going to be your producer surplus. So to get the last step, which is step 4, okay, social surplus, that's just CS plus PS, and that's just equal to 500 plus 1,000, and that's equal to 1,500. And that is your social surplus. So that's how to get your producer and your consumer surplus using an integral. And in the succeeding videos, we're going to deal more with applications of integration as well as applications of economics into mathematics. So thank you for your attention, and I'll see you in the next video. Thank you very much.